So this is going to be the truss practice problem from the sheet that was posted today, April 22nd. This is the first problem on your sheet. So if you've already attempted this problem, you've got the answers, you know whether or not you did it right. I'm going to work out every step of this truss with explanation. I suggest you continue to redo this truss that I'm about to work out until you can do it accurately on your own. So here we go. So here is all of the information that we have on this truss. We're going to go ahead and call these nodes A, B, C, D, and E. The first thing that we need to identify is the reactionary forces. And the reactionary forces occur where the truss makes contact with its support structure, meaning this truss looks as though it's something hanging from a wall. So our reactionary forces are going to occur at C and at A. C is a pin, meaning it has two reactionary forces associated with it, one in the X direction and one in the Y direction. A is a roller that is attached vertically, so it only has a single reactionary force. So at C, I'm going to replace this little pin with the reactionary force at C with respect to X. Then I will have that second reactionary force at C with respect to Y. And at A, we will have just the reactionary force at A with respect to X. So those will be the three reactionary forces that we need to work with. The reactionary force at C with respect to Y is simple. It doesn't have to be split between anything. We have one vertical force coming down here at 50. The only reactionary force we have that can absorb that 50 is RCY. So the reactionary force at C with respect to Y is going to be 50, and it is going to go back up in the direction of Y because this 50 came down. Now we are going to have to calculate the reactionary force of C with respect to X or the reactionary force of A with respect to X. It does not matter which one you choose. I am going to do the reactionary force I'll calculate for A. So what I need to do is say, all right, C will be my pivot point. So I pick my pivot point, and the other reactionary force is the one that I will find. So how do I calculate the reactionary forces? This is using moments. We are going to use the fact this is in static equilibrium, and that means that the sum of all moments at point C must equal 0. Remember that moment is the tendency to turn. So every force has an effect on the moment. And it is about the perpendicular distance of that. I put a 2 right there because we didn't have that distance. It is about the perpendicular distance from the point to the force. Here's what I mean. This 50 is a vertical force. So the horizontal distance from that number back to the pivot point is 5. We also take into account the direction that this 50 is going. So if I'm rotating about this point, this 50 is going to cause rotation this direction all the way around, following that arrow. That is clockwise direction. As we have discussed, clockwise is negative. So we have negative 50 times 3 plus 2 is 5. we have this 100. This is a horizontal force, so we are interested in vertical distance. So the distance is 2. This 3 is not relevant in moment because it is in the same axis as the actual force. The 2 is the perpendicular distance from RCX down to this point B. So that 100 is a distance of 2. And the 100 coming in and going around C in that direction, that is also clockwise. So that is going to be negative 100 times 2. The final force is this reactionary force at A. So we don't know which direction it goes, so that's just going to be reactionary force at A with respect to X, and since it is a horizontal force, the vertical distance is that same 2. Those are all the forces that we have at work in this problem, and so that must sum out to 0. So that gives us negative 250 minus 200 plus 2RAX equals 0. 2RAX equals 450. And so RAX equals 225. Since it is a positive 225, that would put it in the counterclockwise direction. So with respect to this Rx, that's going this way. And so we have this value coming in at 225. So we have now used the moment to calculate that value. We look and see, all right, there is 100 coming in. There's 225 pushing back out. That means that there is another, so we have 100 this way, 225 that way. So we have an extra 125 going in the right direction. So this one has to counteract that. So this is going to be 125 coming this way. Now, the 125, that is the horizontal reactionary force at C, plus the 100, which is the external force at B, going to the left, that's 225 left, and then we have 225 coming to the right at A. So the 225s cancel each other out. We now have the sum of all moments equal to 0. The sum of forces equal to 0. Our reactionary forces are set, and we are ready to move on to the next process. Now, remember, the moment process, that's how we find reactionary forces. Once we have those reactionary forces, now we are going to switch over into calculating the compression and tension of the different beams that we have in this diagram. So I'm going to stop the video here, and we will pick up in the next video talking about the computation of compression and tension for the different beams.